Well, thank you, Peter, for taking time today, and thank you all for joining today's our very first customer summit. We are super delighted for spending the rest of the day with you all and have interesting conversations. Before I began, I wanted to share one of the biggest paradigm shifts that we are seeing in computing. We've come a long way in computing. If you kind of take a step back, the earliest form of computing just a few hundred years ago was Chinese abacus. Then came mechanical computers, such as Charles Babbage differential engine that did basic arithmetic. Then came digital computers. And for the most part, software 1.0 is what we see and practice today. Like most of the world that is built around us is in the paradigm of software 1.0. And the basic idea in this paradigm is that it's about encoding logic. Software programmers break big problems into smaller problems, write a series of logical statements to solve each smaller problem, then compose a solution into a big system. We've made a tremendous progress with software 1.0, and nearly most of the technological feats, such as going to the moon, having great medical system and technologies, this was all based on this software 1.0 paradigm. However, today there is a massive shift in how we teach computers. We are rapidly moving away from writing logical statements to something called data-centric programming, popularly known as software 2.0. Building AI applications are fundamentally different in that instead of software engineers writing logic to solve a problem, domain experts are labeling data, which is then used to train neural networks. Peter, you have written a lot about data is the last fundamental constraint to unlocking the full potential of AI. What are your thoughts there? Can you explain a bit more about that?
Yeah, sure. And thank you, Manu, for inviting me, and welcome everyone. So, when we talk about data being the last fundamental constraint, like it's a big fundamental constraint, simply because you think about computing power is basically unlimited, particularly as we think about the movement towards edge computing, right? Like computing power is unlimited. And to a large degree, the algorithms behind AI are mostly becoming commoditized. That's sort of those elements have already been solved. There's there's massive compute power, and again, the algorithms are there and ready for consumption. But data is really the final point here and the final frontier, but it's complex and messy and unstructured. And so when we talk about it being a fundamental last constraint, there's a lot of work to do to actually get it to be used in the most efficient fashion and be used in effective ways for a variety of pursuits. One of the things that I've noted as one of the important elements, the big breakthrough in making and sort of solving the last fundamental constraint on data is really the collection and processing of that information, right? Like data is everywhere. It's unstructured. It's, we have to collect it. We have to be able to label it, and we have to be able to process it. And, all of that requires a workflow that is suitable for managing and assessing that information. And whether the labeling or the collection is done, whether it's manual or by computer, by algorithm, all of those things need to come together in in my mind, in some workflow that humans can actually interface with to make these massive amounts of data actually be accessible for the algorithms that are going to process that information. So yeah, it's a last constraint, but probably the harder constraint of the three. The algorithms were relatively easy. Compute power has been around, and now we have this, big area here to go solve, is the taming of data.
That makes sense, Peter. And Peter, do you see the data to be kind of sort of a representation of human decisions that the people are making inside the companies?
Do I see them as, what do you mean? What's the,
So I think what we are seeing is that most of the domain experts in these organizations, they are making decisions, like claim adjusters making a decision, or a doctor making a decision about cancer, and essentially they're creating data.
Yeah, I see what you're saying. Let me go back and say the reason, of course, we're investors in Labelbox, and I always love the concept and love what you all are doing. But let me go back a step and say the reason why this whole taming of data and data became important is that I believe, like to your point here, you have claims adjusters, finance people, medical analysts, right? I think that everyone who is an expert actually is going to become a data scientist. And so we all are going to be data scientists in some way, shape, or form, and we need tools for those people to be able to unlock the power of data. I believe that these AI environments and data science is sort of the equivalence of source code, right? But source code only gets written by a human called a computer scientist. And in this, data world, because everyone can really become a data scientist, and in fact is a data scientist, we all practice the art of processing data. I believe that there's going to be a 10x increase in the number of what I'll call data scientists. It's just professionals as opposed to programmers. So what we're doing here is not only moving into a new era, as Manu you describe as 2.0, we're also unlocking the potential for there to be what I would call 10x the number of developers, hundreds of millions of people actually using data for the benefit of the profession that they actually work in. And to me, that's incredibly exciting.
Yeah, totally. I think that's very fascinating, and I believe that this new wave of developers or data programmers would need a new class of tools and technologies and workflows to be highly productive.
Exactly, and maybe I'll turn that question over to you to now pepper you with questions. You and I, we've talked a lot about data prep as an engine powering modern AI, and so help us all to understand why you believe that's the case and what's so important about that.
For sure. So in the last 6 or 7 years, what we have seen is a successful transition from building, basically like writing logic, to using neural nets to emulate a decision making. And this really happened with the advent of ImageNet. Like, these were some of the most prolific algorithms that came from the academic world. But the basic idea was that at that time, compute and the algorithm were just good enough where if you fed some examples of labeled data to these neural nets, they would start to emulate emulate that pattern matching behavior. And that was very profound, because if you look at kind of like how most human decisions or how human learning is done, it's based on a number of examples. And right. Suddenly people started to kind of realize that these neural nets are general purpose computers that if we can figure out how to feed a number of examples of labeled data, it can learn nearly anything. It can learn how to detect cancer cells. It can learn how to detect cars for self-driving vehicles and so forth. And so with this realization comes a big challenge. Well, it turns out creating or converting raw information into structured data is incredibly hard because it usually requires human intervention. And that has become sort of the core focus for most of the organizations that are building AI systems. Like, how are these companies or how are these teams taking their proprietary information that they have in their companies created by applications or services, and turn that into label data that is fed into neural nets, and hopefully that neural nets makes decisions at 100x scale that otherwise couldn't be done.
Right,
and I think that's why data prep has become or data labeling has become one of the kind of most important aspects of any AI company or any AI team around the world.
Yeah. I mean, I understand that and agree. What do you think? I'm curious as to your view on managing and developing training data. Is that similar to developing software, or like, do you think it's fundamentally different? As I said, like, I believe that, we're going to have 10x the number of data scientists, doing real work on data across a variety of professions, right? And do you think that those folks is going to be similar to how we develop software, or is it a totally new thing? What's the similarities, and maybe what are the differences there?
Yeah, that's a great question, and a very interesting one. I think building AI systems are fundamentally similar in many ways to software, but has some very sharp differences. If you look at software development, over the decades, we have basically built tools and workflows that enables incredibly fast iteration. Like, fundamentally, the cornerstone for success in software has been really quick iterations. As an example, like, if I'm a software engineer, I think about a problem, I write a logic, and I run the code and see if it made an error or not. And based on that feedback, I can make changes. And so much so, in fact, this paradigm has proliferated across all of the engineering principles nowadays. Like, that's just how we build technology in highly iterative manner. Turns out AI is no different. Building AI systems is also fundamentally highly iterative because teams are coming with hypotheses to go solve a problem. Then they need to create a lot of training data that ideally would teach the neural net to solve that problem. Then they go train a model and they test if it actually work or not. And then they go back to the drawing board. And this cycle repeats all over again and again and again. So in that sense, like, it's very, very similar to software development. However, the challenges are that the iteration cycle in AI development is incredibly slow. In fact, like, the best AI teams today, they spend as much as 3 to 4 weeks from an idea to a model. Compare this to, like, software development, where an idea to a system can be like in minutes or hours. And that is the kind of fundamental challenge in the industry today that are trying to build AI systems into production. Now, let's look at, like, where the things are different in building AI systems and software systems. Well, classically, software development is logic-based. So you've got the programmers writing logic and creating sort of that rule-based system. AI development is fundamentally different, that it primarily works on data. So there is very minimal logic that teams write to identify a pattern of life in an image or a video. Like, it is fundamentally different. Like, teams are labeling data. They are, like, writing, like, they creating bounding boxes or lines or points, almost as if, like, how a human would teach somebody else by marking on an image, like, hey, this is what a person looks like, or this is what a cancer cell looks like. And that is really the fundamental difference. And because of this difference, the underlying tooling and infrastructure to do this at large scale and to ensure quality controls and to ensure consistency, the industry needs new class of tools and workflows that has never been existed. We can certainly take a lot of inspiration from classical software development for the end-to-end iteration cycle, but it fundamentally requires kind of new class of technology to build AI systems.
Also, as you are talking, and providing insight here. What strikes me, when you said like it often, like let's say software development takes a couple of hours to iterate, whatever, right? A day, a couple of hours. And here these AI systems take weeks, right? The problem with that is that as we move to edge computing, processing power becomes unlimited, the iterative loop actually needs to be very short, right? Because often we're processing real-time information. Let's just say, whether it's a self-driving car or some, image recognition, whatever, as an example. Think about that. We're collecting all this data, now on the edge. And let's say there are new images or new quote unquote labels that need to be defined, right? That gets moved back to some central core to be processed. If that takes weeks to go and manage, we sort of defeat the whole purpose of having the edge compute, right? And so I think actually it's interesting that we have a long way to go. That's why when we talk about this constraint, it's like we have to get equal to software development, just even that, which sort of the workflow and all these AI tools, what Labelbox does and all that will help us get there. But I would argue we need to be 10x faster if we're going to really go and process this information and do iteration in the way that most likely edge computing is going to require us to be able to do, and really be fine-grained about that analysis. I think, that's where I say it's like there's a long way to go, right?
Yeah, I absolutely agree with you, Peter. And these AI systems are fundamentally feedback systems.
Exactly.
So and in real world, there is just so much nuance and diversity that
exactly.
Building a static system wouldn't really be competitive enough for an organization for too long.
Exactly. And that, as you taught, and think about it across every different, I'll call it profession, or every different capability that we have, from traffic management to DNA analysis to cancer analysis to financial analysis to, building inspection, right? Think about all the different data that is going to be needed to be collected, collated, and labeled. And it's all got a lot of it has to be done in real time for it to be ultimately effective. So I think that, look, this is the holy grail of, the 2.0, kind of unfolding. And to the extent we get there, it will unlock tremendous, tremendous power in what we can do from a computing standpoint, right?
Absolutely. And Peter, you think about, obviously, software 2.0 technology stacks a lot. Yeah. Why, in your opinion, does a platform become an important aspect for managing training data?
Yeah. So that's a great question. And it's one of the reasons, look, I believe in workflows and platforms for collaboration. We were investors. I was a very early investor and board member at GitHub. That was a workflow. Really, GitHub is a workflow and collaborative engine for software developers, right? There's an underlying technology at GitHub called Git. Well, just using Git doesn't really do very much unless you add the hub, right? And the hub is the collaborative element of having people work together on software. So that was sort of the first one of these. Another investment that we made is a company called Figma. That's a workflow for designers, right? A whole nother ecosystem of folks. And I view that a platform like what Labelbox is building is a workflow for data scientists. And what it, the importance of it is that data scientists can collaborate together, share their learnings, become smarter about what everyone's doing together, work more efficiently. And that collaborative effort, and whether the labeling is done manually or by algorithm, having people interact and exchange ideas with this platform is what's going to shrink the notion of the iterative loop problem that we just talked about, right? By having just individuals do this in silos without a collaborative effort, it'll be a long road, a long and bumpy road to nowhere. And I just really believe, and I've seen it, in multiple other cases where this notion of platform and collaboration across teams and across different, geographic boundaries really does help to accelerate the efficiency and optimization of an organization. So yeah, I'm a believer in the idea of comprehensive workflows for purposes like this.
Peter, you say a very interesting thing here. So my observation has been, like in GitHub, there's this practice of comments and PR reviews, and these are like programmers. They obviously have made a decision in their code, and they are discoursing and trying to make a better decision. Right. Same thing in Figma. Like we design systems, like design new graphic. We are trying to have a rational discourse with other designer to make a better decision. And what's fascinating is like in data labeling, it's exactly the same thing, because these are fundamentally human decisions. Like right. Two doctors are coming together and saying like, hey, I believe this is a T cell with this cancer type 1. What do you think? Yeah. And ultimately, these guys want to have that collaboration and make a better decision before feeding it to the neural network.
Yeah, exactly. No question about it. In fact, it gets me to think about a question for you relative to this is how do you blend, what is the role of human expertise versus AI-driven automation? And where do those, on one side, I mean, my argument could be completely, sort of not very important. If all this was completely automated, then what do humans have to do with it, right? I don't think that's ever the case. So, sort of how does human and AI and how do these algorithms and machine recognition and all these other bits and pieces all come together to really make this most effective?
Yeah, for sure. So I think I believe that there will be a need for human intervention for quite some time in building these AI systems. And the answer for that is very simple, because the world is just so complex and nuanced. Mm-hmm. And the higher order decisions or interpretations of the world have to continuously to be fed to these AI systems. Because think of like these AI systems to be like, we are on this growth curve. Like the AI systems today are very narrow. They are kind of fairly dumb, but we are making them as modules, and over time we will use them as Lego bricks to make a more higher order decision. So like some of the best AI teams today, they use like 5 or 10 AI models in conjunction to make one higher order decision. So I think with that said, what we are seeing is that with a platform like Labelbox, because our customers are able to integrate their AI models and training data development really close together, what is interesting thing that is happening is that they're now able to leverage AI model that they're training and ask it basically like, hey, do you does this AI model understand this new information? And even if it does with 50% accuracy, well, that's still a decision, and that a human can review at a later time. Yeah. And so what we are starting to see is that these teams are merging human and AI models together to make a faster decision, or in other words, to make as quick decision as possible. And with I think we would see a lot of automation come this way. Because if you have these AI models basically behind a computer screen, and it's basically interrogating the human, like, hey, I don't know anything about this data. Can you tell me? Oh, I know about all of these 5 data pieces. So let's skip that. And so that's how these AI systems are being built today with a platform like Labelbox. And that's really fascinating, because what this all means is that we are getting smarter. AI teams are getting smarter to only use human intervention where it's needed, not to, in just a few years ago, it was all about just having manually labeled data everywhere they can. But now it's very selective and targeted, and it's going to continue to go in that direction.
Yep.
Peter, you've been investors in GitHub and Figma, those are great companies and great products. What made you invest in Labelbox?
Well, as I mentioned before, I believe that there's a whole class of folks out there who are going to be data scientists, and a whole world of new data scientists that are going to require a platform and workflow to operate in. And I very much believe, and now I've been on the board, well, it's been a while now, and love working with the company. It's an awesome company. I think that sort of thesis of what we had originally, sort of thought about is actually coming true. The other part of it, notwithstanding the workflow and kind of this whole new class of folks becoming data scientists, we looked at like the whole sort of how much time is spent in a variety of sort of functions relative to completing a machine learning process, right? And labeling was the #1 time-consuming element in all of the activities having to do with machine learning, right? And so to the extent that, and it was like a big chunk. I mean, it's like if you take like this circle, draw a clock face, it was like from 12 o'clock to 4 o'clock was due to, labeling, and other pieces were actually quite small and little chunks, but it was like a big part of the problem. And my belief is if we can solve that in a fundamental way, using a platform, using workflow, collecting, processing, and sort of managing that information and this massive amount of unstructured data, that's the key. And, so far so good. I mean, that was the thesis. And again, our experience at other companies that had done collaboration and platform and against different constituents of folks really led us to believe that there's a need for a platform for data scientists. And, that was the sort of the industrial logic behind the investment.
Awesome. Well, thank you for that, Peter. How do AI companies more broadly look similar or different than traditional software businesses? Yeah. I'm sure, like when you were thinking about investment in Labelbox, and even today you get to see number of AI companies.
Yeah. So let me say, it's actually interesting when you ask this question. I'm going to broaden it out a little bit here, because as I think about it, I believe that every company is going to be an AI company, which is different than a traditional software business. Like every company, I don't care what the company is. If you are a, medical company, you will become an AI company. Like you have to, like the notion of, when you talk about claims people and finance and medical folks and, whatever, marketing people, AI is going to be used with every function within a company. And I believe that every company becomes an AI company over time. So in that sense, it's very different than, let's say, a traditional software company, because I think these principles of AI sort of underpin, the entire next generation of how literally, our economy works and how all companies can be most competitive. Now, with respect to AI companies that we might invest in versus software companies that we might invest in, look, there's a lot of similarities in, there's a go-to-market, there's building out the technology. The cost structure might be a little different because there's a high degree of, somebody's got to pay for compute, and there's a hosting element. There's a lot of data. I would say that AI companies probably have greater demands on infrastructure for sure because of the amount of data. Like you can't lose the data. You have to label. There's a massive amount of this information. It's all unstructured. So that's very different than, let's say, a typical software company. Even let's say a company like, that's just recording source code, or a company that's, has a lightweight database behind it or whatever. There's a lot of information here that needs to be processed. So a lot of that is different, though. Building out the company and all that. There's many similarities, of course, in delivering the tech and kind of bringing it out to the audience. But macro, I think that every company becomes an AI company, and that's very different than kind of software, though it's, software is permeated everywhere. This is sort of the next double click on that.
Yeah, the world will be very, very different, basically in 5 to 10 years, where most of the companies we are interacting with are essentially some sort of an AI system.
Exactly. And think about, not only are, I believe, companies become AI companies, every software product is going to have a component of AI built into that software product, right? So in some ways, traditional software businesses are going to inherit properties of AI into their own software products, because that, so maybe even entire software companies become AI companies as well, because that's how we're going to get, specificity across every type of vertical, leveraging this underlying dynamic. So
yeah, one interesting thing I've observed in pure AI companies is that, as you mentioned, yes, the infrastructure can be costly, and I think the cost of GPU and so forth continues to decline. But there is also a constant cost structure for labeling data, to process data. And that actually we have never seen in classical software companies to such an extent. And what's really also even more fascinating is that as these AI companies get more success in as they scale their products and services driven by those models, the need for labeling data continues to rise proportionally to the exposure that AI model has in the market. And that's really fascinating, because that I think many people that started AI companies didn't really thought that would be the case, and now they have to kind of work with that.
Yeah, I think that's a double click on this idea that there's massive amounts of data that needs to be, something or someone needs to deal with all that as an infrastructure component, right? And you're right, it is something that's very new, right? Software companies typically don't have to deal with that, for sure.
Yeah.
Maybe talk about, we have talked, and I've certainly written, and I wrote a piece a couple of years ago on edge computing. What do you think about that? And how is edge going to really change this whole AI world? I mean, I have we can talk about this a little bit, because I'm very it's actually happening. I wrote this piece, which was called The End of Cloud Computing, a couple of years ago, where I argued that decisions need to be made at the edge, and this whole feedback loop and all that. How do you see it unfolding? And I think it's happening now, and in what areas and all that, and how are you seeing it?
Yeah, for sure. Well, firstly, I absolutely admire your talk that you gave in 2017. And for those who haven't seen it, please go watch on YouTube. It's one of the most awesome technology talks. I think edge compute is happening. In fact, a number of our customers that are using Labelbox today, they ultimately ship their AI models to the edge, whether it's on robots that are cherry picking tomatoes or strawberries on farms, or killing weeds with tractors, or even devices that are in clinics' room. So in countries like India or Africa, where these devices have to just make a decision on the edge when somebody gets an X-ray. And I think it's really I think what's if you look at kind of where the value creation happens, a lot of value creation or valuable events are actually instant, in the real world. whenever whenever a car hits, has an accident, being able to understand the extent of the accident right away before things change, is really important decision and very valuable decision to make. Similarly, if a farmer is spraying weeds, spraying over the weeds to kill them, that's a very valuable decision right there. And I think we will see more and more of these systems proliferate. Another example actually is security cameras. So what we are seeing in the industry is the concept of watchmen, who would sit 24/7 looking at a bunch of camera feeds to make a decision in real time, is going away. These AI models are now being shipped with the Nest cams and the industrial cams, and they identify people or intrusion automatically and alert a whole the different people. And so the world is just made of a number of these examples where the humans are making decisions on the job right there, and that is augmenting or automated by AI systems, and that is essentially edge compute. Now what the challenge remains is, what is the architecture for building these edge AI systems with sophistication that we make our classical software systems with. It's a really hard problem, because once you have an AI model on the edge making decisions, if it makes a bad decision, you have to capture that data stream or the segment of that data, and then push it back to the cloud to process it. And then the AI teams are regularly kind of capturing all of this information, training a new model. Then they are shipping those new models back into the edge. And that whole infrastructure and that whole dance is super complex, can be very, very slow. Most teams don't even are able to make it within a year, generally speaking, when we look at our customers. And I think we would have to kind of build a lot of tools and infrastructures to make that really easy, almost as much easy as building an app on an iPhone. I kind of always think of these mobile apps sort of as a proxy of edge systems or architecture that we would emulate in AI systems. So I think it's so much of information is being captured from the sensors everywhere. People want to bring value creation right when those streams are being captured, and enormous opportunity for companies to harness that.
Yeah, for sure.
So wrapping up, Peter, what advice you have for companies focused on monetizing AI?
Yeah. So as I said before, every company will be an AI company, and every software product will be an AI product. So just that alone, this is a fundamental shift in, how things are going to work. I think ultimately it's really about reducing complexity in order to increase this notion of the feedback loop, right? The faster we can do this feedback loop and the faster we can iterate around sets of data, the greater efficiency and effectiveness we're going to have and profitability we will have on the output, right? And I think that's really the magic here. To the extent that we can label more quickly, iterate more quickly, reduce complexity on massive amounts of unstructured data, that is going to unlock the power of AI in the way that, certainly I think we all here imagine this industry to unfold.
That makes sense. To that, thank you so much, Peter, for taking time with us. And now we'll open up for some questions.
Great.
And I'm here to help facilitate that. Please, everyone, remember that we have that chat feed to the right side. Please post questions. I think this has been a thought-provoking conversation. I personally have 1,000 questions I'd love to ask these two, but want to make sure that you all have a chance to ask first. So here's one question from the feed for either of you. What industries personally excite you that you think are ripe for AI to solve critical business problems in? Now, I know, Peter, you said every company is going to become an AI company.
Yeah.
I feel like there's certain companies or industries that are sort of ahead of the game that are leading the way toward that evolution of all companies becoming AI.
I mean, I'll start at this. I mean, I've had this vision. Let me go micro here for a slightly micro. I think every department within a company is going to use AI, right? And so that's at one level. The finance department, marketing already, we see AI being used to better target sort of how products get to consumers. The sales organization can use AI to better, affect forecasting, corporate planning, right? So that's a finance function. I think even engineering, right? Like the productivity of developers using, the code they write or the data that they use will all be parts of this. So I think that we've seen SaaS products get built for every part of the operation within an organization: sales, marketing, engineering, finance, legal, HR. Every one of those products, I believe, will have elements of AI built into them to help the efficiency and effectiveness and productivity of an organization. So that's at that level, right? That's at the within a company, and any company can use that. Now, within industries, look, what we're already seeing, certainly medical, right? Let's look at industries where there's lots of visual data to start with. I would say that the medical industry is so ripe for AI, right? And it's just really starting. There's massive amounts of images, and the human benefit of us being able to identify, certain cancers from images or not images, but information about DNA and certain other scientific advancements in medical. I think that area is just like it's great for human progress, and it's very ripe right now for the use of AI, because I think it unlocks a tremendous amount of untapped potential. So that would be one. Manu, you could probably go on a number of these, but that's sort of
yeah, totally. I think certainly like medical has been a big one. I think almost where any industry that has visual decision making, like in construction sites, we see a ton of visual decision making as an example, to understand hard hats or to have some regulatory compliance of the machines working in a certain way. So it's pretty wild, but the visual decision making is going to be very would be automated with AI systems at an incredible pace, because these neural nets are just fundamentally so good to emulate a pattern matching behavior that our eyes do, and it's really across all of the industries.
Yeah, I mean, maybe just as a starting point, any industry that's dependent on large amounts of, I'll say, visual data is a prime candidate for this, right? Like for sure to start with, right?
Yeah, and speaking of healthcare, Genentech's actually going to be speaking later today, so I think that's one great example of how it's being applied.
Yeah.
Sure. Yep. Yep. So here's a question from the audience. What are either of your thoughts on large organizations such as Google and Amazon making more competitive AI products and driving down prices to commodity levels? Is that going to happen, and how's that going to affect things?
I think it's fantastic. Like when we talk about compute and algorithms, what do they do best? Compute and algorithms. It's fantastic, right? GPUs, CPUs, MPUs, BPUs, whatever it is, right? Like any PU in the future, whatever they can do to drive down cost, I think is going to be hugely beneficial for this industry. Now, the real question, it gets back to Manu's point on edge computing. How do those folks play? Like if processing moves to the edge, where is their involvement in that? And how do we see some of those things? But in terms of algorithms and like raw compute power in the cloud, like go for it. Like the greater the commoditization of that level, the better off we're all going to be. And I still think, by the way, there is an absolute requirement for a workflow on top of that and the whole platform to leverage those underlying assets and it's the workflow that ultimately becomes the differentiator, for sure, because that's what makes it easy to actually do the things that are going to be required.
Totally. And in addition to that, these big companies, they are also making AI services products, like to recognize common objects of interest. And I think that's also even actually great, because what we are seeing is that there's a class of problems where the AI systems can be built on a commodity data. Commodity data is data that anybody can kind of capture.
Sure.
A self-driving cars is essentially a commodity data. You can put a camera on a car, and you can collect it and identify people. So these kind of problems where any company can apply commodity data with commodity models, those problems are going to be very likely be just solved by these big companies like Google's and Amazon's. And so the class of AI problems that most organizations ought to be focusing on are the ones that gives them competitive advantage. And if you think about competitive advantage, what is it? Well, it is taking proprietary information in your company and proprietary interpretation on that information and combining that to an AI model. And I think no company, like no Google and Amazon's, can take that away from organizations, because that's what makes a company differentiated in the market. And so I think that we will continue to see trend towards that as well.
All right, so we talked about these giant models. We talked about the power of mass computing. Let's talk a little bit about where people fit into this as we keep evolving. You both mentioned it along the way that people are obviously a very important part of the mix right now in terms of doing the data labeling right now, and the need for a collaborative platform, et cetera, et cetera. But where do we see that going, right? What's the future of manual annotation, essentially?
Yeah, Manu, why don't you take that, since we've talked a lot about this, but you're the expert on this answer.
Totally. I think we'll share more information throughout this event, but the future really is augmented labeling, and as much as automated towards the path to fully automated labeling. Most of our biggest customers today, they actually use their own AI models to pre-label the data, and they only use manual labeling when they think it's needed to improve the model performance. And I think we're going to just start to see more and more of that across the industry. People call it AI assisted or AI augmented labeling systems. That's here. It will continue to get better over the next few years. And I think my guess is in 5-ish years, people are going to do very specific manual labeling, like maybe 10, 20x less than what is required today. If you think of any rate of progress, it compounds, and we are moving towards that path of full, as much automation as possible.
Great. So let's shift. Well, actually, there was one other question here about expertise. I think this is actually related. It seems like part of that path, Manu, is basically it's companies starting to figure out how to scale and automate the expertise that I think is probably the most valuable thing that humans are providing right now. Any thoughts on sort of how that happens? How does that path take place? That computers start to take over some of that expertise from humans, or is that not how you see the evolution happening?
No, I totally see that way. I think if you take an example, we've got a customer or number of companies in agricultural sector. In fact, like we might be the leaders in agricultural sector, and these companies, they are trying to build applications that understand qualities of the plants. So if a farmer puts the seeds, the plants pop out, and there's also weeds and plants. And to kind of understand the diseases on those plants and to understand what's weed or what's not, that's a very expert decision. Like usually requires agronomists. Agronomists are people who are trained through school or certified to kind of do that as a job. And now this craft is limited by number of people and how many they can be on the field at any given time. So there are companies that are building AI systems that basically works with these agronomists. They capture that expertise in label data, and then they have these AI models that basically makes the same decision. And now farmer or grower has a mobile app, and they take a photo of a plant, and they instantly get a idea that this is a disease that they should take care of, in this week. And back in just even a few years ago, that would require that grower to call somebody to come to the farm and inspect that disease on the field. So we are seeing that already. Like, that's basically scaling intelligence or scaling expertise. And by the way, what's really cool is once you have these AI systems, I mean, then you can it can be in everybody's phone like instantly. And so that's a power, because you can get the state-of-the-art expertise of label to everybody with the same consistency, which is super powerful. Even more powerful in medical industry. Like, you can have Stanford level medical professional looking at cancer cells, and once you train an AI based on people who are labeling that data, you can have the models. You can have the system in Africa, and they would have that level of decision making of label to them, to all of those hospitals. And so we're seeing that happen every day.
Excellent. So speaking of decision-making on the field, and you have both talked a lot about edge computing in this talk, question from the audience saying the one thing that seems to be holding back edge computing right now is the lower compute power and speed when compared to cloud or conventional. Do you really think edge is going to get to a place where it can match and operate on par with what we have in cloud and conventional right now?
Yeah, maybe I'll take that. I've thought a lot about this. So one, I think it's a hybrid model. I don't think everything moves to the edge or everything stays to the cloud. If you think about it, the edge is very good, whether it's a video device, a camera, your cell phone, those are all examples of edge devices, a self-driving car. The compute power of each individual edge device is obviously very small. And so the work that gets done by an edge device needs to be very small. So the unit of work being done by an edge device will be appropriate for that edge device. However, there's billions of edge devices. If you added up all the edge processing power, it likely far exceeds the power of the cloud right now. So what's going to happen is the edge, there will be little, I'll call them code fragments, applets that run on the edge that collect information, maybe process some of it on the edge, make some decisions, but all the learning will be done back at the cloud. And so this notion of iterative making decisions at the edge based on a model that's been defined in the cloud, that's how I see things working. So it's less about whether there's more or less compute power in my mind on one side or the other, but more to, are we effectively using the compute power in the best way possible? And if you can because if I can move an applet out to the edge, I'll use that word, whatever, a little fragment of code out to the edge, and it's closest to where the data is actually being collected and can respond to that instantaneously, that's a big win. I don't have to wait for latency or have a network connection or whatever. And then all the learning and iteration by collecting millions or billions of edge device examples and data back into a central repository, and then doing the labeling and the massaging and then sending the model back out to all the edge devices. I think that's how it's going to work. And that will give us a 1 + 1 = 3 on, edge and cloud all kind of working together. That's how I kind of see things unfolding.
Yeah, really interesting vision. And to Manu's point, if you haven't watched the future of cloud computing talk,
that was basically what I said. So you don't need to watch it anymore, because that's what
I love it. Well, speaking of, we talked about quick and sort of right to the point. So would love either of your thoughts on enabling no-code AI model creation, where everyday people can create their own label data and AI model to solve any problem they want. Is that a realistic view? I see you shaking your head, Peter.
Yes. I mean, if we're going to have 10x the number of people, if everyone becomes a data scientist, then absolutely, that's where it has to go, for sure. Be an expert in your field, not in data science, right? And I think that's where we have to go take things. And, we're on the path there. We have to be.
Manu, any other thoughts on that?
I agree with that. I think in a world where everything is sort of AI, then there is kind of ways to build. There would be ways to build AI systems. Number of ways to build AI systems. No code for sure. I think we are already seeing a lot of signal there in the market. And then there will be systems that will require certification and complex engineering, just because those decisions that the AI systems are making have a lot of high consequences. And so I think we'll see a pretty broad spectrum of kind of ways people will create AI systems. I think to Peter's point is that in that world, I think we will start to basically make complex systems as easy as make very complex systems very simple. And I think that's certainly what we have seen in software development. We're going to see that in AI for sure.
Yeah.
All right, so we've talked a bit about where we're headed. We've talked a lot about sort of where this future is. Let's come back closer to the present now. So what are your thoughts right now on hiring and attracting the best talent for AI-centric companies versus, we're sort of moving from this age of software-centric to AI-centric? How hard is it to attract that talent right now? And what does that change? What does that evolution look like?
Yeah, I think there's certainly a difference in hiring AI talent. I think the key distinction that everyone should make is that how much of their work is R&D and science-based work versus like building industrial AI applications in production. Because what we are seeing is that those are completely two distinct skill sets in the AI field. To build production AI systems, it requires basically data engineering, more or less. I mean, it doesn't require somebody to know the science behind neural networks and so forth. Like that is already gone. Like the algorithms are commodity. They are like Lego modules. You just have to plug them in the right slot and then build this intricate data pipeline. And also, what's really important about this kind of talent is that these people have to understand the business really well, the business logic, like what are they trying to solve for core products and services. So that is data engineering with, of course, some ML background. More and more developers are becoming these data engineers now, because building AI systems is becoming straightforward because it's becoming modular and you just plumb things together, very similar to software development. Like if you make a modern software app today, I would argue that most of the work is plumbing different services together, and that's what AI is becoming. Now, if your problems are unknown, there's a lot of ambiguity. That's where you might have to index more on research scientists and people who can really understand the neural networks and the science behind it and so forth. And what's fascinating is that mostly every school that I can think of that in North America teaches AI today, which wasn't really the case even 5 years ago. So I think we're going to just see more and more talent emerge both ways. But it's important to decide what kind of talent you need to go after.
I think also I agree with all of that. One of the ideas as well for organizations that may not have the talent is to do some retraining of the existing workforce into this new data science and engineering world. There's a lot of, online material. I mean, I'm on the board of a company, Udacity, that actually has really great training classes on data science and engineering, such that the whole idea is to, retrain the workforce in this new area. And I think that'd be an interesting way to go about doing it in the event that, you can't go and hire specific data scientists or data engineers to go do things. So that's another idea.
That's an excellent point, Peter, because I think from our vantage point, we are seeing that like our enterprise customers, they have developers who are moving to machine learning field, and now because the tools and workflows are becoming ubiquitous or very easily available, as well as there's just so much content that people can learn and become an AI engineer today. Totally.
Yeah.
All right, we have time for a few more questions. Last call for the chat feed, but here's one. So, Manu, you were talking earlier about the challenge of some of the cost structure, right? There continue to be the cost keeps going up because there's so much data to wrangle, and a lot of that is because this long tail, right? There's the bulk of the cases which can be addressed, I think, fairly easily with automation, but there's this sort of this long tail, and I guess I would love to hear your thoughts on that long tail. How far does that go? How easy is that to start to tackle? We talked about automation starting to take over the role of expertise, but what about sort of this long tail of those edge cases? I think we've all seen the Tesla talk about there's always another stop sign that hasn't been figured out where the branch is blocking the view, whatever. How hard is that to tackle using automation versus, continually putting more human and cost into it?
It certainly is a difficult problem, but I think it's long tail challenge. It might not be for every single AI company. So it really depends on how what kind of problem a team is solving. So, for example, if a company is trying to automate inspection on an assembly line, and most of the parts, they kind of look and feel the same. It's a controlled environment. You've always got the light of certain color. The camera sensors are unified. Like that actually is a very far narrower problem than, let's say, solving self-driving car, where it's a wild system. Like you don't have any control to it. It can be day, night, snow, rain, and top of it, there are people who does random things. So to build AI system for the former case is far easier, and you don't actually have that much long tail problem versus solving kind of a very generic, broader real world case. So I think it's important to make that distinction, because for sure we are seeing AI systems that have superhuman accuracy in these narrow domains, and people are achieving that really quickly in a span of 6 months to a year, and they get into production. For the cases where the problems are more nuanced, and I would argue that these problems are actually even higher value, generally speaking, because they are so nuanced, and because that's where humans are making decisions there. There is definitely long tail. These are all of the edge cases that come up, and I think the key is to create a infrastructure that enables this team to iterate really faster, because the only way to tame this long tail is to be able to iterate, in a very high speed, and create a system that you can perpetually keep iterating your systems. That really is the way I think I can think of that helps solves that. I think in addition to having faster iterations, integrating these data kind of workflows with the AI models is equally important, so that in every iteration, the teams are becoming smarter and only using human intervention or human labeling where it has the most ROI. Like there's no need to label all of the data manually anymore. Like you have to create systems where you are able to just use insights of the poor performance of the model and find the data that will fix that problem.
Any final thoughts to add, Peter?
No, this has been fantastic. Thank you all for, these are great questions. And Manu, thank you for all the awesome questions. I'm thrilled to just see the participation and interest in, what a couple of years ago was like an arcane area of like computer science and all this, and now it's really becoming the forefront of the next generation of computing. So, it's again, thank you all, and have a great day with the rest of the program.
Yeah, thank you for being such a great way to kick off this day. And next up, so everyone knows, is Emma Bassen from Blue River Technologies. She's going to be thrilled, I think, because so much of what you two talked about, they are already applying at Blue River Technologies. So as I mentioned earlier, there's going to be this pause where we come off the screen. but we will be right back with Emma. So please stick with us. We'll be back in a minute or less. Thank you.
Thank you, Peter.